kcse division channel. I am teacher James Marita from the Old Boys High School. Kindly subscribe to my channel, click the notification bell such that you get notified once I upload a new video. Today we are looking at for manual work, our topic 3. The topic is simple classification of substances. We are looking at the methods of separation of substance. We have various methods of separating substance in this simple classification. We talk of one we talk of a simple distillation method, and then we have a question that was set in kcse 2023, which is dealing with the fractional distillation. So today I'm presenting to you the simple distillation method, and then we have the fractional distillation, and then finally we have the separation using a separating funnel. So as you can see on this diagram, that we have around 3 diagrams here. We have the simple distillation method, whereby the method is used to separate the substances which have a wide range difference of boiling points. For instance, here you talk about a mixture of salt and water. Salt and water, they have a very large difference boiling points, so they can be separated using a simple distillation. Then when you talk about the fractional distillation method is normally used to separate substances which have very close but different boiling points. So in this simple distillation, as you can see, what are some of the features we have? We have the light condenser. This is what we call the light condenser. Then this light condenser, it has water in and water out. So it has water out from the upper part, and then we have water in from the lower part. And of course we have the flask. We have a round bottom flask which is used to heat the substance. And the reason why we are using the round bottom flask, it is for equal distribution of heat. Then we have a conical flask here which can be used to correct the distillate. So this is a mixture of salt and water. A mixture of salt and water normally makes a solvent. We divide what is a solute, what is a solvent, and what is a saturated solution. So in this case, when we have salt and water, this one here, salt and water, they normally make a solvent. So they normally make a solution. Salt is a solute and water is a solvent. So you need to understand that. So this one here, it is a solvent. This is a solvent, a liquid in which a solute dissolves, and a salt, this one here, we call it is a solute. A solute is a substance, and a solute is a substance which dissolves in a liquid. So water, a mixture of salt and water is an example of a solvent. So they have different, very large boiling points. How do you separate them? They are separated using a simple distillation method. So what are some of the things that you are supposed to understand from this here? We have a light condenser. The purpose of the light condenser is to condense the vapor to liquid. So we have this one is normally to condense the vapor to liquid. Then we have the water in and the water in the lower part, and then we have the water in, the water out in the upper part. And this one here, it is to ensure that there is an efficient condensation and vaporization for any of these in this case. So the purpose of this one, why do we have water in and water out? It is because this one we can have for efficient vaporization or condensation. Now, what is the application of this simple distillation? The application of this simple distillation, it is for purification of distilled water. So it can be used for water purification. Top of the manufacture of wines and spirits, you have the production of a bottled pure water, and then we have distillation of seawater to obtain pure water. If water in, as you can see, if water in and water out can be interchanged in such a way that instead of having water out here, we have water in and then we have water out. So that one, if the water in and the water out is interchanged, we are not going to have the efficient condensation or what we call the efficient vaporization. So water in and water out should not be interchanged. For efficient vaporization or for efficient condensation, then we should have water out at the upper part and then we have the water in from the lower part. So if you can compare that one, in kcse 2023, question number 26, there was a question here that was dealing with the separation of two liquids, and the method is a fractional distillation. So understanding that there is a difference between the simple distillation method and the fractional distillation method. In the simple distillation method is normally used to separate the substances which have a very wide boiling points, and in fractional distillation, it is normally used to separate the substances which have close but different boiling points in that case. So in the case 2023, there were two questions here. There were this fractional distillation that was separating two liquids. One liquid was liquid Q, which has a boiling point of 117, and then we have another liquid was liquid R, which has a boiling point of 103 degrees. So of course we have water in, and then we have water out. You can check what we have from the simple distillation here. We have water out here, and then we have water in for efficient condensation and efficient vaporization. But here in this case, as you can see, we have water in and then we have water out. We have water in the upper part, then we have water out from the lower part. In this case also we have the fractionating column here. We have a fractionating column, and then we have the water part. This is a water part, and then we have a liquid mixture. So the candidates were required to identify the three mistakes that was done in this experiment. So many students, quite a number of students, did not answer this question well. Many of them did not understand, and quite a number of it leaves the question blank without giving the correct answers. So they were to check that there is water in and water out. Because the water in here, and then we have water out. So if this one will be interchanged, then there will be no efficient vaporization, and therefore there is no efficient condensation. So one mistake is that there is interchange of water in and water out. So water in and water out is interchanged. So if water in and water out is interchanged, then there is no effective condensation or effective vaporization. That is one mistake. So they were supposed to identify the mistake and to give the reasons for each mistake. Then the second mistake you can see from there is that you can see where the thermometer is being placed. The thermometer is the thermometer, this one here, is too far inside the column, as you can see. So this thermometer is too far away, is too far inside the column. So it should be at the end of the adapter, at the end of this point here, because it is normally used to measure the temperature of the water vapor. So that is a mistake because the thermometer is far inside the column. Then the other mistake is to give the candidates just the reason that water has a boiling point of 100 degrees. And these two liquids which are being separated, liquid Q has a boiling point of 117. So the boiling point is above that of water. Again, the liquid R, it has a boiling point of 103 degrees. This one also, it has also, the boiling point is above that of water. Water point is at 100 degrees. And therefore, there is this use of water part. Water part, normally water point is at 100 degrees. So the use of water part, the liquid normally have a higher boiling point than that of water. Therefore, they will not boil at 100 degrees. Another thing that you can see here that in this fractionating column, there must be the glass plates. The glass plates in this case is to make the fractionating column long enough. So it is normally missing. So we don't have the glass plates here, which normally makes the fractionating column in this case long enough. Now, what is some of the advantage of this fractionating, the advantage of this fractional distillation? This is a simple distillation method, and this one is a fractional distillation. So sometimes if you are required to give the advantage of this fractional distillation, one advantage you can see this one here, it is precise. It allows for precision, in that case, separation, and it allows for precise separation even when dealing with components with similar boiling points. So another advantage of this fractional distillation, you can also say it is efficient. It is efficient because you can say that it can separate the components it can separate components in just a single process. So in a single process, it can separate multiple of components. So another advantage of this one is, so you can also say it is a resource conversion. So you can see that is a reusing of recovered solvents. It uses reusing of recovered solvents. It conserves valuable resources, and also in that case, it reduces the waste. So we're going to give the advantage of that one. That's what you can say. So there is another separation technique here, whereby you talk of a use of a separating funnel. So this method it is use of a separating funnel. So if you require to give the name of the method is just use of a separating funnel, whereby we have kerosene and water. Water and kerosene in that case they do not mix. They make normally two layers. Kerosene in that case, why water and the kerosene do not mix? Kerosene is a mixture of hydrocarbons, as some of you have done organic chem. That kerosene is a mixture of hydrocarbons. Hydrocarbons, these are the compounds which are made up of carbon and hydrogen only. In kerosene, all these hydrocarbons are non-polar compounds. The non-polar compounds, they cannot attract water molecules because water has hydrogen bonding. The water molecules cannot be attracted to a non-polar compounds, and that is the reason why kerosene and water normally they do not mix. Kerosene and water normally in this case they form a two separate layers. So there is a term normally given, we call it the avoidance. So we have the avoidance. So we have this term here, avoidance. Avoidance in this case, this is a group of compounds or mixtures which normally makes two layers. So if you require to give examples of avoidance, like one example, you have kerosene and water. So this one we have kerosene. So we have this is kerosene and water. Is an example of this avoidance. And also you can talk about oil and water. So we have this is oil, and so we have oil and water. So oil and water are an examples of the avoidance, whereby they form two layers, or sometimes we call them the heterogeneous mixture. So what makes it possible to separate water and kerosene through this method? Through using the separation method, because there is a difference in the densities of the solution. Water and the kerosene normally have different densities. Then also you can talk about immiscibility of the liquids. Immiscibility of the liquid means that the water and the kerosene in this case, they do not mix, they form two layers, therefore they can be easily separated. That is a very simple presentation of the simple distillation method, the fractional distillation method, and then we have the use of a separate refinery. In my next video, I will be discussing on the another separation techniques we use by using the chromatography. Don't forget to subscribe my channel, watch and share. Thank you for watching.